Every solar system is now shrouded in a light, surrounded by a ball. He focuses on the escaping solar energy can be used in a civilized manner for public office, causing the entire galaxy to become dim. This is from a book called Sci-Fi Fragments for Stylers by British author Olaf Stapleton, written in 1937. He was the first to propose the use of a massive star, the idea of an intermodal dynamo. This generator will be used by a highly developed cosmic civilization. Mathematician Freeman Day Sen wrote an article in 1960. It is recommended that this megastructure, it's called the Stapleton Sphere. But other science fiction writers use dye. The name Maury Sphere made it famous. However, in the past half-century, we're not even close. The opportunity to implement such a megastructure, because to do this, we have to disassemble Mercury somehow. Then on Sun peak, and the attractive force of the Sun, balance this huge sphere. After all, how do we transmit the extracted solar energy to the ground? It's not clear on the ball. Despite this, in science fiction books, in movies and video games, there are many other equally famous megastructures. They might be more practical or worth a try in terms of effort and expense. In this video, you will learn how realistic is it to build a gateway to stardom? What kind of space building would be safer? What is the greatest drawback of a giant spaceship? Should we build science fiction or not? Giant structures in fiction. Or are they just too impractical? Even on the first manned spaceflight, before 1960, Soviet engineer Yuri Satnov proposed building a giant elevator to save rocket fuel, transporting cargo and passengers directly to low orbit. Now this may seem like a bizarre idea at first. A long way, time goes unnoticed, until the legendary British science fiction writer Arthur Clarke met Ustinov, his 1979 novel The Fountain of Heaven. Finally, the space elevator concept really caught on. It attracted the attention of real engineers. Even with the advancements in rocket technology, shipping, the problem of sending goods and people to low Earth orbit still exists. Final proof. Clarke describes himself. The above-mentioned method of building a space elevator is the most practical. So let's start with this. You launch a space station into a forbidden orbit, then lower the cable from there to the Earth's surface and fix it. It sounds so simple, but the cable length must reach 35,790 kilometers. That's a cable that would go almost around the Earth. A week late. But here's the thing. Even with the strongest metal alloys, cables can also weigh thousands of tons. Therefore, it will collapse under its own weight when stretched, not to mention being able to stay in orbit. Necessary counterweight. Clarke himself admitted, using traditional materials, building a space elevator is physically impossible. However, as a science fiction writer, he envisions a new type of super-strong, ultralight material, ultrafine silk according to the school. He was in the laboratory at the end of the 20th century, made the most impressive thing. This actually happened, or at least something similar happened in 1991. Japanese scientists synthesized the first batch of nanoparticles. These materials are much stronger than similar materials. Lighter if a space elevator were possible. He only needs this material. Although after 30 years of trying, engineers managed to synthesize the longest, 14 centimeters inner tube. Even these are priceless. And here's the interesting thing. Clarke, the engineers in the novel face the same problem. Ultrafine filaments are only mass-produced on asteroids. To solve this problem, that is to say, people have only put thousands of tons of factories first, equipment and related personnel, after being transported to a farther asteroid. Just built this for a cheap unit and cargo into orbit. But do we really need a space elevator? In fact, the main argument against its construction, it doesn't even involve production difficulties. In a novel based on Isaac Asimov's adapted TV drama base, One by a powerful space elevator built by a galactic civilization, the victim of a group of suicide bombers, just a few explosions. This megastructure, it falls on the heads of the people who pass by. Materials can be arbitrarily strong and lightweight, but most importantly, it's in a state of dynamic tension. Such a high-powered man make a slight push. It could cause catastrophe on a cosmic scale. So spend trillions of dollars to build a giant elevator. Is it worth it? And one with a few $1,000s, terrorists with homemade bombs, could destroy him? However, in science fiction, there are other very useful structures for holding traffic. Their protection against malicious actors, much better. As early as 1942, Ghanaian masterpiece, Home Alfred Elton van Moult, write a book named Secret Unreachable Stories. It tells the story of a Nazi scientist discovered a portal to another planet, used to extract resources for the Empire's war machine. But the concept of stargates, the real popularity is the 1990 film of the same name. He showed how many people, small portals to other planets. However, many science fiction writers have written about spacecraft. We developed this concept, and we envisioned real megastructures. These structures allow people to travel between stars and, sometimes or at least extremely, fast travel. But there are such things, more practical. In Zero Prime Minister, build ringstones several kilometers or miles in diameter. A relative level. It's an engineering task that's achievable today. Although this transportation, the way is usually in the realm of fiction. They're mostly wormholes, and the simple answer is this. It's the space that connects to distant points in space. Bridge. The way to create impulses today is not known, but in the past, full games, one of the most realistic and ingenious technologies has been realized. In this game, Stargate Gate is only used in double specific attractive force resonances found in star systems. It's been scientifically proven. This is an absolutely real phenomenon. Considering the attractive force we create, the structure of space-time. Suppose that one day they will open up opportunities for us. Let's create the actual Stargate. Enable the spacecraft to cross in time, galaxies light years apart. This is not far-fetched. In the game, from 10 to 80 kilometers in diameter, unequal Stargate. The internet connects all major locations. Due to its huge size, separate hubs are extremely difficult to destroy. The main drawback of this transportation megastructure is that to establish contact with the new district. So let's start with this. You have to get there in the usual slow way. But if this technology is possible in reality, he seems to be the most practical means of star travel. Due to the fact that individual ships, the many difficulties posed by accelerating faster than light. More from a physics perspective. Anyway, even if humans are destined to live in our solar system, stay for millions of years, there are also many megastructures. It can be used to expand our capabilities. Living space, building in space. Is a sci-fi giant living area worth it? 1976. Physics Plus Gerald O'Neill in his book, In the High Frontier, proposed quite a scientific plan for colonizing low Earth orbit using giant space stations. The so-called O'Neill cylinder is 30 kilometers long, 8 kilometers in diameter. The internal area is up to 1,300 square kilometers. It rotates every 2 minutes. Can be activated internally, Earth-like artificial gravity, with an adjustable mirror system. Our sun provides him with light. O'Neill wants a cylinder like this, become regularly self-sufficient. A self-sufficient colony, own farms and water bodies, forests that grow food and produce oxygen. 50,000 can live comfortably. We're at Christopher Nolan's Interstellar, saw a similar space living area. But Cooper Station is just over 1 kilometer in diameter. It's 1/5 the size of O'Neill's original design. Babylon 5 is the same size. Although he is not a colony, it's a transportation hub. 250,000 can occupy at the same time. That is to say, using fairly compact life knowledge technologies. O'Neill cylinder, it can be a resident, a metropolis with millions of residents. What about the Stanford Circular Space Station? In the same book, it's a circular space station. Estimated resident population from 10,000, 1.5 kilometers in diameter. The largest Stanford, Circular Space Station version is a movie blessing. The Elysium Space Station, an astonishing 60 kilometers in diameter, 500,000 the most. The rich are up there in incredible luxury, life, and the Earth became a slum. In fact, this is the most highly regarded performance from O'Neill's book Any Space, an accurate description of the living quarters. No matter its size, its construction will assume astronomical costs, enough to bankrupt every country on Earth. O'Neill's simplest project, at least 3 million tons of construction materials, equivalent to 500 Great Pyramids, without a future like the space elevator, means of transportation. The cost of getting all this stuff to orbit will reach $6,000 trillion. That's tens of thousands of times the GDP of the global economy today. O'Neill suggests, by transporting from asteroids material to lower the space cylinder and the cost of the circular space station. But developing such an industry is another expensive stage. It hinders us from achieving our goals. However, there is not enough money in the world to resolve the main issues. According to O'Neill, build an absolute necessity for a living space. It's a robust system to protect people from cosmic radiation. And NASA engineers still can't make it friendly enough. Materials that can shield from dangerous radiation. For example, only during the first half of the International Space Station, radiation metering for astronauts. It's the back of their lives on Earth. Therefore, if we don't solve this problem, Ren, how can we build eternity so hard in space? Gigantic structure. In a few years, it will become a giant tomb. However, Roche, academics at the University of Stuttgart, a solution has recently been proposed, can combine radiation threat and cost issues simultaneously. That is to put existing asteroids into an O'Neill cylinder, even small fragments that are only half a kilometer in diameter. It is also possible that scientists believe they can be wrapped in a super strong membrane. It's a bigger membrane, folded several times, and it unfolds like an umbrella. Shattered asteroid debris, under the action of centrifugal force, collected on the inner surface of the membrane. Result, they will have a cylinder with a diameter of 3 kilometers, thick wall, enough to provide adequate radiation protection. Our budget space living quarters are ready. However, this project is like a space elevator, need to use currently. The uninvented is equally powerful. Ultralight nanomaterials to make membranes. So does this mean that we will have to drop all classes? What about similar plans? Look now, skyscrapers have glass, constructed of plastic, steel, and concrete. These seems to be something from previous fantasies and novels. Notre Dame took nearly 200 years, built under tremendous resource constraints. It's just that the technology hasn't gotten there yet. We can build it in space, inhabited megastructures. We were at the same level, too early to be practical. But the world of science fiction used to be full, 20,000 years ahead of our world. Here it is, giant structures that players guide, with our ground-level skyscrapers, compared to the Empire State Building. They almost look like toys. The extra housing space station is about 40 kilometers in diameter, much more than the grandest O'Neill lineage, and it required a lot of resources to build it. But these resources are mined through existing mines, infrastructure, and its own engineering behemoths. Complex provides, and furthermore, he doesn't need any spinning skills. Because of the drive, interstellar, the technology of the gate makes it possible to reach any point in space, create attractive force wells, become possible. It is more than just a habitat. It's also a spaceport, warehouses and armed outposts. In other words, he's a bastion for small companies or groups of players. Now, we can't even build an extra house, but in an era of active development of many star systems, he will become another familiar and the megastructure of utility. Imagine that. We have reached this advanced level. There is no advanced future space world without giant spacecraft. But why do we need them? Short stories in the 1930s. Tonya Winks, author under the pseudonym Alondra Septima, speak. It was built for 400 people, almost a kilometer long. the story of the giant ark, but only their distant descendants. It will take thousands of years to reach its destination. This is science fiction, the so-called history of fiction, the first mention of a generation spacecraft, although many later writers did not specify such an ark size. But this massive structure has to be maintained. Thousands of people live for a long time, so from a practical point of view, they must have a strong life knowledge system. In James Carey's science fiction series, Silverless Space, Rich Moorman built a starship called No. Essentially, it is a strong, an updated O'Neill cylinder for the big engine, designed to ensure delivery. 4,000 people and their descendants travel to TNSA T12 light-years from Earth, galaxies in the Silverless Space event of the 24th century. It's human, the largest structure ever built, including spacecraft and space stations. But no one never set out. Because in the conflict between Earth and Mars, soldiers from the Outer Star Alliance stole in, transform it into a military giant cruiser. Later it turned out, single torpedo hit. All systems are paralyzed for a period of time. That's not surprising, because No was originally designed as a civilian spacecraft. At the same time, a battleship in Silverless Space is much smaller than an ark. This is obvious from a practical point of view. The bigger your ship is, the less mobile he is, the easier it is to get hit. George Lucas is writing the famous 20th century film, Star Wars. I don't seem to be worried about that. Consider Star Wars. The Galactic Empire has a vast fleet. Its core consists of more than a kilometer-long interstellar destroyer composition. Each ship is basically a platform for various weapons, from fighter jets to assault carriers. In other words, he is in space. Aircraft carrier. Considering the aircraft carrier, it is the largest warship on Earth today. It is easy to draw conclusions. Interstellar conflict will require even greater fat loss. At the same time, as can be seen from the famous Star Wars battle, Star Destroyers are quite durable, can withstand multiple hits. But even so, they were also on Darth Vader himself. National Fleet, period. Next to the 93-kilometer-long Arrowhead Executor, Eclipse. According to its description, he could destroy an entire fleet on his own, or 10 entire planets. It's not inhabitable. In fact, this ship doesn't even need to shoot. Appearance of the Executor, it is already provoking the enemy to surrender to the Empire, or wishes, but if you think about it. In the final battle against the rebels, the Executor's control tower suffered a single hit, just enough to make him lose control and crash. It seems rather impractical, but on the other hand, what can you expect? After all, even after the first execution was destroyed, they still started building a second Death Star. The diameter of the Death Star is 120 to 160 kilometers. It's about the width of some Japanese islands. Therefore, they are one of the largest warships in the Kahun. But regardless of the Death Star's reactor, how vulnerable is the core? This giant ship can hold up after shooting. It's impossible to be intact. According to the rigorous calculations of Star Wars fans, a deadly super laser could destroy an entire planet. Has an astronomical energy of 60 billion gigajoule miscons. This number has more than 30 zeros, almost 2 million times our solar output. This means that after each discharge, dead lasers don't just melt targets. It would also significantly heat up the space station itself. In our atmosphere, oxygen absorbs excess heat, but in the vacuum of space, heat has nowhere to go. Therefore, the discharge produces, the remaining heat generated will enter the megastructure itself. No cooling system can prevent its devastating melting. So from a practical point of view, giant warships are almost impossible to become astronomical energy platform for super weapons. Wang Mengzhang's flagship battleship is called Titan needs to be more balanced. Their size, it's on par with the Star Wars Executor. Length varies from 13 kilometers to 18 kilometers. These giant ships, only one or more layers of crop protection after 25 meters, unable to pass the refinement of the superstructure. Shoot to destroy, only through. Other Titan's doomsday weapons, a salvo to completely destroy, depending on the faction. He could be a powerful laser, antimatter bomb or missile salvo. In terms of explosive power, all these super weapons, both are equivalent to 20 kiloton nuclear bombs. When you think it's not enough, don't worry, Titan was able to actually handle the damage from such a company. Heat dissipation from string attacks. In the early 1970s, from California Jet Propulsion, laboratory scientist Don Alderson proposed an idea to a science fiction writer. It's about a giant inhabited disk. This megastructure will replace all interior planets. Alderson's disk is over 240 million kilometers in diameter. Beyond the orbit of Mars, its thickness is almost 5,000 kilometers. Really only circles a narrow band in the middle of a plate. It's livable, but even so, this region is also larger than the surface of the Earth, 50 million times bigger. All of this sounds absolutely crazy. The author of 2 Malibu cartoons, including famous science fiction writer Larry Niven, created a whole, set in Alderson's circle, the story of each region. It's called the chakra. Actually, creating such a giant world is only suitable for the gods. It's not just about producing enough. The issue of high-grade durable building materials. The total weight of this material is equivalent to that of a star. No matter how strong they are, without some magical intervention, gravity will immediately round Alderson. The disk becomes an old-fashioned sphere. Larry Niven himself admitted he believes that this megastructure, it's purely a science fiction fantasy setting. He designed a more realistic and practical artificial giant world. In the book Around the World, he described a disk between Alderson and Stanford Circle, artificial giant rings between space stations. This is an artificial ring around a star, diameter of 150 million km. That's about the size of the Earth's orbit. It's only a kilometer thick, provided by, that's 3 million habitable planets. It's home to trillions of people. The annulus is fixed inside by rotating everything. Surface provides 99.2% of the same artificial gravity as Earth. According to Niven's calculations, create such a giant world, we need to move Jupiter, transformed into a super durable building material. This is for a first. It is feasible for advanced space civilizations, even if someone points out the tidal forces of the star will rapidly disrupt and destroy the ring. Niven is also in foreign aid. Added powerful rocket engines, make continuous adjustments. But for writer Ian Banks, the world is not enough. In the 2008 novel Substance, he envisioned a giant orbiting a star. Topulos, forming a giant Archimedes spiral, offers more than Niven's circle of the world, hundreds of times more habitable. Build and balance. Such a structure is extremely complex. But here's the main problem. Why is this effort being made at such an advanced level of space engineering? The habitable zone around a star, creating rings with attractive force balance, will be easier. Although there may not be thousands of places, the ball is so vast. But the inhabitants of such a system, we don't live in fear of a cataclysm. In addition, there is no shortage of sun-like stars in the Milky Way galaxy. So why place all your bets in a giant basket? From a practical perspective, a highly developed civilization may be more willing to key position creation in space. It's not a giant artificial world. Many smaller worlds. Manjong in the past, the largest megastructure. It is the castle known as Bauxing, altitude up to 160 kilometers. Much like the second Death Star, it can carry millions of people and thousands of ships. Compare Bauxing to a superstar like Shanghai. Metropolitan Port is the easiest, but he also served as take control of the new military base for the entire week. In a castle like this, only involve thousands of players and many others. The largest battle of Titan will happen. The destruction of a single treasure was an extraordinary event, enough to make headlines for all gaming news. So, will humans one day be able to build species? Something like that. If we were like the civilization in Human, explore space, create stargates to other galaxies, transporting giant ships and battleships between them, then there will undoubtedly be interstellar conflict in the future. In that future, such a megastructure will inevitably become the largest faction and national army, the foundation of power.